Hello there, Math 112 fans. Going to continue our preparation for Quiz 2. This is going to be the Winter 2019 question 3. And my goal here is to really get us to hammer down those, chapters 10, 11, and 12 concepts, which all tie together. Okay, so I'm going to do a few questions. I'm going to continue to talk about how to do this. This one isn't a business example. It's just an amount of something. Sometimes we do one that's like the height of a balloon. Sometimes we do one that's the amount of water in a tank. So it is good to read a question and realize, okay, they're telling me that A of T is the amount in vat A. in gallons, and they're telling me that B of T is the amount. And there should always be these moments when you read the question, you think about that a little bit. So then you go, what are they telling me? They're telling me the derivative of A, so that's the rate, and they're telling me the amount in vat B. And they're telling me that they start at the same amount. Okay, so when you read question A, you should be always thinking about what are you given and what do you want. This one is a chapter 12 question. Why do I say that? Because what I'm given is the derivative of A. So the quiz will have some, I would consider this a small chapter 12 exercise. Exam 2 will have a little more of this, just direct. But you should realize they gave you the derivative and they told you the initial starting amount. They said the initial starting amount of A is the same as the initial starting amount as B, and you can see that that's 30 when you plug in 0. And so this question is asking you, can you find A of T? So that's a direct chapter 12 question. You're going to integrate or think antiderivative. We've played this game quite a bit now. Coefficients come down, plus and minus comes down, and there's this weird plus C. So you've been doing a lot of this lately. So this becomes t cubed. There's a 1/3 out in front, but it cancels the 3, so you get this. This becomes t squared. There's a 1/2 out in front, but it cancels and makes this a 9. This becomes 15t, and this becomes a constant. Then you use that initial condition to figure out what c is. That's what we've been talking about. So this is 30, this is 0, this is 0, this is 0, because we're plugging in 0. So c is 30, and we're done. So that's this concept we've been playing around with in chapter 12. And definitely by the time you do the quiz, you'll have done lots of these. Okay, so that's one thing. So that's less of a problem-solving type problem. You didn't really need the full process I've been giving you. But still just a skill we need kind of in that step 1. So let's keep going. So the next question, and then this is just for those folks that say, I don't know what function, I don't know how to read these questions. It says, find all times when A of T. This question's about A of T. So first, if you want, the first thing you could write is this, but since I already have it written there, I'm just going to leave it. Has a point of inflection. Point of inflection is talking about concavity. So you would have to remember that. And so we are going to do second derivative stuff. Second derivative of what? Second derivative of whatever the question's about. So we need the second derivative of A. So that one you can do fairly quickly. So the second derivative of A, we already had the first derivative. So second derivative is negative 6t plus 18. Set that equal to 0, and I think you're going to get t equals 3. You're then going to draw this number line, and you're going to say, what can I say about the second derivative when I'm less than 3? Like if I plug in a 0 or a 1, it's positive, which means it's part of a smile, the original function. If I plug in something bigger than 3, like a 5 or a 6 or a 7 or a 10, it's going to be negative. You can actually plug it in if you can't see that. So this is indeed a point of inflection because the concavity changes. And I'll finish this with some visuals of those if you're still confused by this, but I hope you're seeing how quick these can be. What's the question about A of T? Then it's about a point of inflection, so I need to find the second derivative. Find when it's equal to 0. Find the highest amount in vat A. This is part of what's great about this is that we can answer a lot of questions quickly without having to graph it or look something up. It's just so easy to do this. And it gives you the ability to analyze things, even when you don't know all the numbers. Okay, so highest amount in VAT A. This is asking about VAT A. And it's asking about the biggest amount. So it's a maximum question. So we can reset our thinking. I hope this is sort of helping. So let's scroll down here. Let's grab this, move it down. Keep going. Highest, max. So it's a max question. We're asking about A of t. And it's a global max question because they give us an interval. So that's, this sort of question we've been talking about. What's the biggest on 0 to 7? So these questions always end with plugging in your endpoints and your critical points. And there could be none, there could be 1, there could be 2. In this case, there's going to be 2. I just know because I have already looked at this problem. But we're going to compute 4 things. And we're going to do that by plugging in. This is probably the most tedious problem on here. It's because you have to plug in. But I know that one of those things is the answer. For example, I could plug in 0. So anytime it says what's the biggest and smallest over an interval, that's what you were doing in 10.3. You had several questions like this. It's asking you to plug into your original function. What's your original function? It's the function the question's asking about. Sorry to sort of hit this point so hard, but this is the big question I've been getting from students. So we know that all is going to happen, and we're going to try to see the biggest of these things. But are there more things we have to consider? Yeah, you have to consider the endpoints, but are there any critical points? So we need the derivative, and we need that whenever we're doing a max question. The first derivative is negative 3 squared plus 18t minus 15. We set that equal to 0. This is kind of a big question because you might have to use a quadratic formula or solve. I'm not going to show every piece because I just want to talk about ideas. I would encourage you to try that. The quadratic formula gives me 2 things. I plug those in as well. Again, tedious. I do negative 1 cubed plus 9 times 1 squared. But I know one of these is the answer. Negative 5 squared out cubed plus 9 times 5 squared plus 15 times 5 plus 30. I'm running into my process here, so let's move this over a little bit. And erase. And now I know one of those is the answer. This one is 30, and I have these worked out over here. This one is 23. This one is 55. This one is 23. This is the winner, 55 gallons. Now, I'll show you some visuals of that if you're still having trouble with those ideas. The next question is the same idea. What is the highest? But this time it's about the rate of change of B. That's B prime. So this is more just an understanding question. B prime is negative 2t plus 8. And this is where I remember students, when we were asked this, they got confused. But this is your starting function. This is like your original function. And the question is asking, when is this biggest if you're between 0 and 7? And that was really the goal of this question, was to check if students are reading carefully. The original function is B prime. Now I want to know a max question. So I need to take the derivative of this, because that's what the question's about, and then I need to do a global max question. Now in this case, when you take the derivative of this, it's never 0. And so this question, we're almost done. Do you know how to finish? We know we need to plug this in to whatever the question's asking about. We know we need to plug this into whatever the question is about. And then we need to take whatever we got from this and also plug it in. That's that idea. Okay, so we need negative 2, 0 plus 8, which is 8. We need negative 2, 7 plus 8, which is negative 6. So the answer is 8. So that's the biggest of those. So that is thought process, but I wanted to finish this out with some visuals here. Okay, so what we did first is we were given this derivative. This is on the left is A, on the right is B. So the left tells you the amount of gallons in VAT. That's just graphing that formula. And the point is, this took me a long time to graph it. It's much faster for me to actually solve the questions than to go graph it, which is part of your skills. I hope you can leave this course and have the ability to analyze a function and not have to go find a graph or figure out how to input it. Okay, so here you go. Initially, this was going down. There was this low point at 1. We found that in part C. That was one of our critical points, one of our bumps. We also found that there was a bump at 5. We also found that in part C. And we also found that when you plugged it in, you got 55, which was the global max. Those were places where the derivative was 0. Okay. Yeah. And then we found when it was steepest right here. That's the point of inflection. That's a place where you had the highest slope, but it's a place where its derivative was 0. We call that a point of inflection. And then lastly, for B, we found when the derivative was highest, when it was steepest. Now the derivative is highest right there. That's when it was steepest. But it really was asking about this graph and when it was biggest. Notice that that graph's always concave down, and so there are no critical points of this. There's no inflection points. That's what we're doing here. I don't know if the graph helps or not, but it reinforces what I've been telling you. All right. Hope that's helpful. I will do the winter 2018 exam in a future video. Just trying to slip this in where I could into my schedule. All right. Hope that helps.